There's a powder that costs $1. It removes rust rings, calcium deposits, and decades of hard water staining from a bathtub surface permanently. Not lighter, not managed, gone. Professional hotel housekeeping operations and marine restoration crews have used it for over a century. They did not stop using it because it failed. They stopped mentioning it because a powder that solves the problem permanently after one application cannot generate repeat sales. And what cannot generate repeat sales cannot sustain a $200 billion industry. This is the story of the $1 powder the cleaning industry prayed you would never find. Welcome to Unearthed Lab. The powder is oxalic acid, first isolated in 1776 by a Swedish pharmacy clerk named Carl Wilhelm Scheele. Scheele was not wealthy or institutionally supported. He conducted experiments after hours in a cramped Uppsala laboratory using borrowed equipment and secondhand chemicals. That evening, Scheele was reducing liquid extracted from sorrel leaves. White crystals formed at the bottom of his flask. He documented their sharp, sour character and their remarkable ability to dissolve mineral deposits and rust stains on contact. He published his findings. The scientific community ignored them. Scheele died in 1786 at 43 years old, poisoned by the chemicals he spent his life studying. His discovery of oxalic acid was buried in academic journals written in Latin and Swedish. For over a century, almost no one outside chemistry departments knew what he had found. Then, in 1882, something accidental happened in Indianapolis, Indiana. A manufacturing chemist named George William Hoffman was cooking rhubarb for dinner. When he finished, he noticed that the pot, tarnished for years with mineral deposits and grease that no scrubbing had removed, was gleaming. Hoffman understood immediately that the rhubarb contained something chemically significant. He isolated the active compound. It was oxalic acid, the same substance Scheele had crystallized from sorrel over a century earlier. Hoffman formulated a cleaning powder built around oxalic acid and began selling it in brown paper bags to taverns across the Midwest. Barkeepers used it to polish brass rails, copper kettles, and iron stovetops. Word spread from saloon to saloon across Indiana, then across the entire country. He named it after his most loyal customers, Barkeeper's Friend. By the turn of the century, it was in hardware stores from New York to San Francisco. 140 years later, the exact same formula is still manufactured in Indianapolis. Same oxalic acid, same mechanism, same results. Nothing about the chemistry has changed because nothing needed to change. The powder already worked perfectly in 1882. The cleaning mechanism is not subtle. It is chemically absolute. When oxalic acid contacts iron oxide, the compound we call rust, a double displacement reaction occurs at the molecular level. The oxalate ions bond with the iron ions and form iron oxalate, a compound that is completely water-soluble. The stain does not get pushed around or masked with a white film. It gets chemically disassembled at the molecular level and rinsed away as if it never existed. This is fundamentally different from what commercial bathroom cleaners do. Most spray bottles on the shelf use surfactants, soap molecules, to loosen surface grime and float it away temporarily. But mineral deposits, rust rings, calcium scale, and hard water staining are not surface grime. They are chemically bonded to the porcelain or enamel at a molecular level. Soap cannot break those bonds. Scrubbing cannot break those bonds. Only a chemical reaction targeting the specific mineral compound can dissolve them permanently. Oxalic acid does exactly that, and it has for over a century. Research on chelation chemistry confirms that oxalic acid binds with calcium, iron, and magnesium ions more aggressively than any common household surfactant. It works on porcelain, enamel, fiberglass, ceramic tile, and stainless steel without damaging the surface beneath the stain. This is why one application of a $1 powder accomplishes what 50 bottles of bathroom spray cannot. The spray manages the surface. The powder resolves the chemistry. The cleaning industry understands this distinction precisely. Hotel housekeeping departments have used oxalic acid solutions to restore bathtubs between guests for decades. Marine restoration crews use it to strip mineral deposits from fiberglass hulls. Woodworkers use it to bleach water stains from aged lumber. Industrial cleaning operations buy oxalic acid in 55-pound bulk bags because nothing else works as effectively at that scale. The professionals have known for decades. The industry has known for decades. The only people who were not told are the ones paying $15 a bottle for products designed not to work permanently. The global household cleaning products market generates over $200 billion in revenue every year. Surface cleaners alone account for more than $68 billion of that total. Bathroom cleaning products represent one of the fastest growing segments in the entire category. Every product on that shelf is engineered around one foundational principle: repeat purchase. A spray that removes surface grime today ensures you need another bottle next month. A foam that temporarily whitens a tub guarantees you will be back in the cleaning aisle within weeks. A product that eliminates the stain permanently, that makes itself unnecessary after a single application, is the cleaning industry's worst economic nightmare. The industry did not ban oxalic acid. It did not fight it directly. It did something far more effective. It ignored it. It flooded the market with hundreds of competing products in bright packaging with scientific-sounding names. It spent billions on advertising campaigns that trained consumers to believe cleaning is a weekly ritual requiring specialized branded products. The goal was not to defeat the powder. It was to make the powder invisible. It made the cleaning aisle so overwhelming, so crowded, so loud, that a plain container of oxalic acid powder on the bottom shelf became invisible. That is not conspiracy. That is shelf placement economics, and it has worked for 70 years. A standard bottle of branded bathroom cleaner costs between $8 and $15. The average American household buys 6 to 12 bottles of bathroom cleaning products every year, between $70 and $180 annually, on products that manage stains but never eliminate them. Over a decade, one family spends between $700 and $1,800 on bathroom cleaners alone. A single $2 container of oxalic acid powder lasts an entire year at pennies per application. The cost difference is not a preference. It is the cost of not knowing what the professional sector has always known. A single $2 container of oxalic acid powder contains enough material for dozens of applications and lasts an entire year. The cost per application is measured in cents. When stains become too deep for spray bottles, homeowners call a professional. The bathtub reglazing industry charges between $300 and $600 for a single refinishing job. Bathtub replacement starts at $1,500 and can exceed $8,000 with installation and tile work. Every dollar of that expense could have been prevented by a powder costing less than a cup of coffee. The mineral bonds that accumulate into requiring professional reglazing are the same bonds oxalic acid dissolves in 20 minutes. That is not a preference claim. It is a chemistry claim. Several premium bathroom restoration products list oxalic acid as their active ingredient, sold to professional cleaning services at $40 to $60 per container. Hotel housekeeping supply contracts specify the same compound as the standard restoration solution. Same chemistry, different label, 40 to 1 markup. The same compound, a different label, a 40 to 1 markup on the identical chemistry. Oxalic acid is not a specialty chemical. It is a naturally occurring compound found in spinach, rhubarb, and dozens of common vegetables. The human body produces it metabolically. It has been classified as safe for consumer use since its commercial introduction in the late 19th century. The professional-only framing applied to oxalic acid in commercial marketing is not a safety classification. It is a pricing mechanism. The compound is available at any hardware store in the paint section or wood restoration section, labeled as wood bleach, for between $1 and $3. Go to the hardware store paint section, not the cleaning aisle. Find oxalic acid powder or wood bleach. The cleaning aisle will not have it, and that is intentional. Put on rubber gloves and safety glasses. This is a mild acid requiring appropriate precaution. Mix 2 tablespoons of powder into 1 quart of warm water in a plastic bucket and stir until completely dissolved. Ensure the bathroom is ventilated before applying. Apply the solution to the stained surface using a sponge or spray bottle. Let it sit for 10 to 20 minutes. For severe staining accumulated over decades, allow up to 30 minutes. Do not scrub. The chemistry does the work. The oxalic acid is already dissolving the mineral bonds at the molecular level. Scrubbing is not only unnecessary, it interrupts the chelation process before it completes. The reaction needs contact time, not mechanical force. After the dwell period, rinse thoroughly with clean water. The yellow discoloration is gone, the rust rings are gone, and the calcium scale is gone. What is visible beneath is the original porcelain or enamel surface, hidden under mineral accumulation for years, possibly decades. For staining accumulated over 20 or 30 years, a second application at 3 tablespoons per quart resolves what the first pass did not reach. In almost every case, 2 applications restore a bathtub most homeowners would have paid $500 to reglaze. After the final rinse, dry with a clean towel. Total material cost, under $1. Total time, under 30 minutes, 0 scrubbing required. I need to be honest with you about something. Oxalic acid is effective and the chemistry is real, but it demands respect. Always wear rubber gloves and eye protection without exception. Never mix it with bleach or any other cleaning chemical. The combination produces toxic gas. Keep it away from children and pets, and store it in its original container with the label visible. This is not a toy, it is a tool. And like any powerful tool, it works brilliantly when used correctly and rinsed thoroughly afterward. There is a surface limitation. Oxalic acid is safe for porcelain, enamel, fiberglass, ceramic tile, and stainless steel. But marble, travertine, and limestone will etch under acid exposure. Confirm your tub material before applying. The core argument holds for every other bathroom surface. Your grandparents knew this powder. Their generation did not have a 50-foot cleaning aisle telling them what to buy. They had a tin of powder under the sink, and their bathtubs were spotless. Then the industry grew, the advertising expanded, and the shelves multiplied. A simple permanent solution was slowly pushed to the back of the store and buried under an empire of repeat purchase products. The powder did not disappear because it failed. It disappeared because it worked too well. A product that eliminates the need for itself is the cleaning industry's worst nightmare. The chemistry does not care about brand strategy. Iron oxalate does not check the price of the spray bottle next to it on the shelf. The powder is still there, still costing under $1, still doing in 20 minutes what an entire aisle of products cannot accomplish in 20 years. The science did not change and the formula did not expire. They just stopped telling you about it. If you have made it this far, you already know more about bathroom surface chemistry than 99% of homeowners, property managers, and cleaning product buyers combined. Subscribe and share this with someone who is still paying $15 a bottle for a product designed never to finish the job.